Okay, concavity, concave. Basically, is the cup upright or is it upside down? If you think about a coffee cup holds water when it's upright, dumps out water when it's upside down. Okay? Coffee cup is down. It pours out. Okay? From here to here, coffee cup is up. Coffee cup down, coffee cup up, coffee cup down, coffee cup up. So, about from here to here, it's concave down. From here to about here, it's concave up. From here till about here, it's concave down. From here till about here, it's concave up. From here to about here, it's concave down. And from here to here, it's concave up. Do you see how that works? Up? Yep. Right. Well, I'll show you how to figure out those exact points. Okay. But for right now, it's just understanding that these things are called points of inflection. Points of inflection are where the concavity changes. That's super important. Okay. So now we'll start out with easy. Okay. What is the first derivative tell you about a line? Slope. The second derivative tells you concavity. First derivative tells you slope. Second derivative tells you concavity. Now, it asks in this question, where's the slope? Negative, and the concavity negative, or where is it concave down? So where is the slope? Down. Where's the line going down? And the coffee cup pouring out. Well, the slope is down right here, and it's down right there. That's our two places where the slope is negative, right? Otherwise, the slope is positive there. So it's either here or here. Now, is this concave up or concave down over here? Concave up. So we're looking for concave down, so it must be this area where it's concave down and slope going down. So that is from 1 to 3, basically. Okay? Slope is down, and it's concave down. Where is the slope positive, but still concave down? Well, the slope is positive from here to here, from here to here, from here to here. The slope is positive there. Okay. It's concave down. Let me do this in a different color. It's concave down from here to here, from here to here, and from here on. Okay? Concave down here, concave down here, concave down here. Okay? So, if you look at it, -4 to -3, it's concave down and its slope is up. So that works, right? From 0 to 1, it's concave down and its slope is up. That works. From 4 to 4.5, it's concave down and its slope is up. So that works. So that's 3 answers. Okay? All right. A twice differentiable function means that you can take the second derivative. So then you can figure out concavity, basically. Okay? Which points are points of inflection? Where does it change concavity? Okay? Does it change concavity at A? Yes, it sure does. Because it's concave down here and then changes to concave up here. Okay? Does it change concavity at B? It's concave up here. Isn't it concave down here? So, yes. What about C? Yes. What about D? No, it's concave up here and it's still concave up. Okay? Does it change concavity here at A? No. At B? At C? At D? It's always concave up, so it doesn't change concavity there. Okay, so there are no points of inflection there. Here, A, B, and C are all points of inflection. What about here? Is A a point of inflection? Does it change concavity? No, I don't see a change in concavity. It just looks like concave down. Is B a change in concavity? No, because that's a maximum point. Is C a change in concavity? Yes. How about D? No. Okay. So those are points of inflection where it changes concavity. All right. So now, when you actually have a function, how do you find concavity? Well, if you're a cheater, you grab your graphing calculator and you graph it. Okay? But if you're not a cheater, then you start taking derivatives. What's the first derivative of this? Negative 20x to the third plus 12x squared minus 20. What's the second derivative of this? Okay, you set the second derivative equal to 0 to find points of inflection. Okay, what can you take out of this? What goes into 60 and 24? Negative 12. So if you take out a negative 12, you get negative 12x, and you get 5x minus 2. So x equals 0 and x equals 2/5. 2/5. Okay, so number line. Here's 0. Here's 2/5. Now, if you take a test number in between these, okay, you can figure out if it's concave up or concave down. So what's a test number in between two of these? 1/5, right? 0.2. Well, 1/10 would work too. Yeah. But let's say 1/5. Sure. What's negative 12 times 1/5? A negative number, right? And 5 times 1/5 is 1. 1 minus 2 is a negative number, right? A negative times a negative is a positive. So it's concave up right here. If it has a point of inflection, it should change concavity. It should, unless it's a double root. Okay? So let's try a 1 in here, because 1 is on this side. It makes this negative, makes this positive, so it's a negative, so it's concave down. Over here, if we try negative 1, makes this positive, but this negative, so it's negative, so it's concave down. Where is it concave up? Just in between those two, which is right there. That's all done via math, not looking at a graph. Now, is it totally easier to look at a graph? Yep. But you might not get to use your graphing calculator on that section of the AP exam. So, you got to know how to do it this way. So you plug the numbers into the second derivative? Plug them into the second derivative that are in between to figure out if it's concave up or concave down. Okay? So this one, I would totally graph this one because it makes it so easy. But, because trying to do derivatives on this, not very fun. Okay? But if we just look at the graph once, if you just plug, chug, and solve, who was that? You didn't have her as a teacher. Oh, you had Weebs? Yeah. Oh, Weebs. All right. If you plug in a 2, what happens? The bottom is 0, so it's an asymptote. Okay, so if you plug in a 0, you get a negative over a negative, which is a positive. You're positive somewhere over here. If you plug in like a negative 4, it's a negative over a negative, which is a positive. Let's plug in a 1 once. A negative over a negative, which is a positive 5. Okay? Because if you plug in 0, it's like 5/2, positive 5/2. If you plug in a 1, it's 5. So 5/2, 5. So what's happening is it's going up like this. So on the other side, it would be going like this. Okay, so that's what the graph looks like. Which one is concave down? To the right side of that. Okay, sometimes it's a whole lot. I mean, even if you're making just a basic graph, not looking at your graphing calculator because you're not allowed to use it, you can make a basic graph a lot faster than you can try to do second derivatives of that bad boy. Okay? All right. All right. How do you figure out if something's a minimum, maximum, or whatever? Okay. At -6, we have a value of -1. That's a point. At -6, its first derivative is 0. So the slope is 0, so it's either a minimum or a maximum. It's either going like this or it's like this. Okay? The second derivative is -3. So it's concave down because it's negative. Second derivative negative makes it concave down. So since it's concave down, it looks like that. So that point will be a maximum. Okay, let's do another one. At 6, we're at 7 up here somewhere. At 6, its slope is 0. So either a parabola there or a parabola there. At 6, it is 0. Ooh, it's a change of inflection and slope is 0. So it either goes like this. See how it's concave down, concave up, or it goes like this. Bingo! There's not enough information because we can't tell for sure. Okay? Can't tell for sure. Okay, so that's the before lunch stuff. So you're going to have more stuff that you can do than before lunch. There are some videos that are really long. I'm sorry. I apologize. But they do a very good job of explaining some things that you might need to know for your AP test. So on your own time over the next few days, check out those videos. But while you're in class, let's bang out some homework here. So after lunch, we're going to do more stuff. That's